Okay.
They will get notification.
Sir,
Good morning, evening. Okay, so good evening, everyone. Durga Prasad, Manish, Sharanya, Ashok. So good evening, everyone. Call your friends quickly. Okay, we will start with the class now. Thanmay, Hari Surya, Kaushik, Dinesh. So can you remind Manish once what we studied in the last class? I think in the last class we were talking about ionization energy. Your syllabus is still electron affinity. Okay. And in ionization energy, we studied factors affecting ionization energy. The last point which we have done is your electronic configuration, I think. Am I correct? Applications not completed. Okay. Up to electronic configuration we have done, na? Okay, fine. Acha, we have done that sudden jump thing, sudden jump in ionization energy. We have done something like that. Sudden jump in ionization energy, stable oxidation state case. No. No. Okay. Okay. ठीक है. Fine. Rakesh. ठीक है. Shanya. So we'll do that part also today in the application section. So mainly we have to do today that is your exceptional cases. We have seen the basic part. What is in the basic part? Mainly we have to deal today with the exceptional cases. But before studying that, I have told you two things. That is your electronic configuration. So half filled case, I have told you. They can ask you a question like this also. Ki, which of the following gives ionization energy of nitrogen and oxygen? They are asking respectively. Respectively means first you should give the answer of nitrogen and then you should give the answer of oxygen. Suppose I am giving any random data. First value is 6.6, 8.6. Then we are having 6.6, 6.6 in electron volt. Suppose I am writing. Then the third value is 8.6, 8.6, and the fourth value is 8.6, 6.6. So what do you think according to you is the correct answer? So we'll start with a question only. Call your friends quickly because I think today's class was not mentioned in the timetable. So it may happen that they don't know that we have a class and they will get the notification a bit late. So it's better you tell your friends. Clear about this? So okay, what do you think in this? So see, we don't have to say like this, sir, I don't remember the value of ionization energy. You have not told the value. Value is not required. We have to just know the order trend. So what is the order? We know that whose ionization energy is more, nitrogen or oxygen? Whose ionization energy is more? Okay, letter informed in the group, na? Okay, very good. Around what time it was informed? Okay, we know that nitrogen is more because it is having NP3 configuration. So you have to find a value in which first value is more and the second value is less, and the correct answer is this. Correct? Done? Okay. Chalo, theek hai. So one more question we can do before starting anything. Like suppose I'm giving you three values. ठीक है ना? Suppose I'm giving कि we are talking about ionization energy. So I have told you कि consecutive ionization energy increases. ठीक है ना? So like suppose we are having aluminium. Okay, we will remove one electron. I will get aluminium plus gaseous atom. Suppose this value of ionization energy 1 is x. ठीक है ना? And next I am applying ionization G2 also. I am having Al plus gas and I will get Al2 plus gas plus 1 electron. Okay, now we are having ionization G2 value, that is your Y, and then we are having Al3 plus, sorry, from 2 plus, again I will get Al3 plus. So we are consecutive applying different ionization energy. This is ionization G3 and this value is Z. So what you can comment on the value of XYZ? Okay, fine. What you can comment on the value of XYZ? Vinay. So everyone is writing, sir, you have told us कि consecutive ionization energy always increases and you are removing one electron. ठीक है ना? So it is everyone knows this कि Z is more than Y and Y is more than X. Clear with this point? One more question is there. This was one of the question. One more question is like this कि they will ask you कि find Al plus 3 electron to Al3 plus, sorry, the electron part will come on that side. So Al gas, Al3 plus 3 electron. What will be the delta H for this reaction? If I ask you this, what will be the delta H for this reaction? Then what you will say? Everyone join quickly. Okay, this is the last class for today. Okay, tomorrow again we can have classes. On Sunday we will also have the class, na? So finally my question is like this कि I want Al to Al3 plus 3 electron, then what will be the value of delta H? Can you tell? So you can clearly say, see, Bhavya is saying कि sir, you can just add all the above three reactions. It is clearly visible. If I will add all the reaction, I will get this. These terms will be cancelled out. So adding 1, 2, 3. What will happen? Adding 1, 2 and 3. I will get this reaction. Now we know when we add any reaction, then delta H value is also added. So what will happen when you will add? Delta H will become X plus Y plus Z. Clear? Very good. Other people, are you able to tell this? देखो एक बार जल्दी. दिनेश, हरीश, रन्य, विनय, विजय, मनीष, फारिदा, कौशिक. Are you able to tell this point कि delta H reaction is X plus Y plus Z? This we study in thermodynamics also कि when we are adding two equation, delta H is added. When we are reversing the equation, delta H sign changes. All of you are able to see this? Okay, two Bhavya are there. चलो ठीक है, फाइन. So these are two questions which we have to keep in mind. ठीक है ना? Done? Okay. So now let's talk about the exceptional cases. Let's talk about the exceptional cases of ionization energy. ठीक है ना? So I am writing few points in the beginning. Those are more important and generally questions are asked from that only. Whenever you see any question of ionization energy, then all the exceptions should come in your mind. कि अच्छा, these exceptions were there. First you should check for the exceptions. कि is the question belonging to these exceptions? If yes, give the correct answer. If no, then you go through the full process. But first of all, you should think about exceptions. ठीक है? Because generally what happens, if 4 questions are there, na, then 2 questions, 3 questions are on the exception part only. Clear? Okay. So very good. You are telling me also. If you know it, you can tell. No problem. So we will talk about group 13. Group 13 means what? Boron family. What are the elements present there? Boron, aluminium, gallium, indium, and thallium. So down the group, ionization energy should increase or decrease? Down the group, ionization energy should decrease or increase? Although all the points we have already written, explanation thing, it decreases. Down the group, ionization energy should decrease. Thallium should be minimum. But this does not happen. Thallium comes here and gallium is more than aluminium. Aluminium is less. So if we will talk about the reason, now we know the reason. Whatever you are saying the reason for size, similar thing will be for this also. Clear? So see, do you remember something about the size part? We said ki in gallium, what was there? 3d electrons were there. 3d electrons, shielding is very poor. So final order can be written like this. If I make this switch, then it will be boron. After boron, what will be there? Thallium. Then we will have gallium. Then we will have aluminium. And then we will have indium. Like this. Now what is happening? Down the group, ionization energy is decreasing. So what you are seeing here, ki gallium is more than aluminium. How you can explain this? Poor shielding of d orbital. Very good. So you can write here poor shielding of 10 3d electrons. See what is happening here? All the reasons are same. If there is poor shielding, Z effective will increase. Z effective affects the size also and ionization energy also. If Z effective increases, size will decrease. Z effective increases, ionization energy will increase. So the reason is always same only. So poor shielding of 10 3d electrons which are filled before gallium. Some people are also saying it as D contraction, 3D contraction. So you say, it is correct only. Other way of saying. If they ask you a question like this, why ionization energy of thallium is more than expected value, then what you will say? More than expected value. What will be the reason of this? Batao. People are joining late. Lanthanoid contraction. Correct. You can say lanthanoid contraction or you can say poor shielding of which orbital? Jaldi batao. Poor shielding of 4f. Correct. So you can say poor shielding of 4f. Poor shielding of 4f electrons. Or you can also say lanthanoid contraction. Okay. Lanthanoid contraction. Your choice. So we have discussed all these things before also. Done? Okay. Nice. Have you prepared for the test? You are having 2 tests this time, I think. Rajeshwari. Okay, so one point is this. See, we can remember this in many ways, but I find this way only very easy. What I do, I write first the normal elements, then I put 2 arrows. Done. Over. Similarly, I do in group 14 also. In group 14 also we have some problem. What is there in group 14? Suppose you are having group 14, which are the elements present in group 14? Carbon, silicon, germanium, tin and lead. Now what you have to simply do? Simply exchange these 2. That means what? PB is more than SN. PB is more than SN. Very good, Bhavyashri. So done. That's it. So I just believe in doing this. Put the arrow, 1 2 arrow you will put. You will remember everything. Okay, now come to the next exception. So what is the next exception or irregularity or anomalous thing is that we will talk about group 2. This I have told you in electronic configuration also. We will talk about group 2 and group 13. We will talk about group 2 and group 13. Now do you know which elements are present in group 2? Everyone knows this, sir. Very easy. See, group 2 contains beryllium, magnesium, calcium, strontium, barium. Who are present in group 30? Again, very easy, sir. I can write here boron, aluminium, gallium, indium, and thallium. We are mainly interested in first 3 elements. What we have told you in the electronic configuration part, I have told you this key group 2 elements like beryllium is more than boron, magnesium is more than aluminium, calcium is more than gallium. Is this correct? Okay. So why this is happening? They will ask you ki why beryllium is more than boron. Then what reason we have given ki beryllium is 2s2, boron is 2s2, 2p1. Here electrons are removed from 2s. Here electrons are removed from 2p. So 2 reasons we were giving. Can you tell me the 2 reasons? What you are writing? Electron gain enthalpy is also in the syllabus, na? Till what point they have told? After this, after ionization energy, exceptions we will write, we will move to electron gain enthalpy. Yes, correct. So 2 reasons are this, ki first reason is it is fully filled. And second reason you will say, ki sir, orbit is same. So I can apply here penetration effect also. 2s is closer to the nucleus, so difficult to remove. 2p is away from the nucleus, so easily removed. So you can say ki 2s orbital is more penetrated, what you can say, more penetrated than which orbital? 2p. Okay? So 2s orbital electrons are more penetrated than 2p electrons. You can say like this. Okay? So it is easier to remove electron from 2p as compared to 2s. Okay? So these points you have to remember. Now you will say, sir, what about the last 2? See, now in last 2, that is your 5th and 6th period, there is no exception. But I don't want to write this. Generally, this penetration effect and electronic configuration have no effect in the 5th and 6th period. Okay. Why this is happening? Because we know in 5th and 6th period the Z effective part is very high due to poor shielding. So Z effective is more. Ionization energy increases regularly. There is no exception. But generally this is not asked in the question. Okay, na? So that's why I don't focus on this part, because what happens na, we want to learn everything and we forget. So it's better to study less and remember it. Most of the questions you will find in any book, anywhere, they are mainly interested in upper 3 elements only. So that's why I'm not writing for 5th and 6th. Although you can write one point. What point you can write? Ki electronic configuration. And what you can write? Ki electronic configuration and what? Pairing, penetration power. PP means what? Penetration power is not much significant. Is not much significant in which orbital? Batao. In which period? In 5th and 6th period. Because Z effective is very high. Poor shielding of 4f. Poor shielding of 4d orbitals. So what will happen? Z effective will be high, normal trend is there. So I'm not focusing much on this. One more change was there which we have already studied. Can you tell me about that change? Group 15 and which group you are telling? Jaldi bolo. Group 15 and group 16. Where it is? Kaha gaya? Group 16. So group 16. So again I am writing here which elements? Nitrogen, phosphorus, arsenic, antimony, bismuth, in which we are not interested. Oxygen, sulfur, selenium, we will only talk about them. Sulfur, selenium, tellurium, polonium. Who will be more? Nitrogen will be more, phosphorus will be more, arsenic will be more. What is the reason? So you tell the reason. What is the reason for this? Can anyone tell the reason? That is your half filled. This one was NP3 configuration, half filled. So we have written all these points already. ठीक है, last two no exception, ठीक है ना, but I am not writing because I don't want to focus there only. ठीक है ना, I want to mainly focus on upper parts from where the question is generally asked. Clear with this point? Okay, done. Now what we have to do, बताओ अब क्या करने का है? ठीक है, okay, fine. So these were 2 points. Now we are moving to the third exception. See, importance is also like this. Okay, first, in which sequence we are studying now, that is also the sequence of importance of the exception. First, they will ask more and more question based on this. Now the third point which we are studying, that is a D block exception. ठीक है ना? Now this is means less asked. You can say less in the questions also you will find. So I'm writing this at last. What we have to see in this, जल्दी बताओ क्या बोलने का है? So do you know what are the exceptions in this? कि we are having 3D series, we are having 4D series, and we are having 5D series. Again you will say, sir, normal trend is this कि down the group ionization energy will decrease. ठीक है, down the group ionization energy will decrease. So 3D should be more than 4D and than 5D. Normal, like suppose I'm talking about third group we are having scandium and we are having yttrium and we are having lanthanum. What is atomic number? 21. Yttrium is your 39 and lanthanum is your 57. So who should have maximum ionization energy? Scandium, then yttrium, then lanthanum. Normal trend. Saranya, this which you are telling, this was for size. ठीक है ना? Although the reason is same. So see, in size also, do you remember, was there any exception in the third group? First you tell me, everyone tell this point, everyone tell this point. First you tell this point, was there any irregular trend in the size of third group till lanthanum? No. All the problem started after third group. What is the after third group? There is fourth group. Which are the elements present? Titanium, zirconium, hafnium, 21, 22, 39, 40, 57. But here we have 72. Clear? So here we were having 14,4f electrons, poor shielding, Z effective increased. So now see here, I am telling you again, listen carefully. Z effective is the reason for size. Z effective is also the reason for ionization energy. Z effective increases, size decreased. Z effective increased, ionization energy increased. Clear with this point? Now when the size decreased, it was almost similar. Hafnium became similar to zirconium. But ionization energy to become more. Ionization energy becomes more than 4D series. Hafnium is having more ionization energy than zirconium. So the order is like this, it decreases till 4D. But if you compare 4D and 5D, 5D is more. And the reason we know. So niobium is there, tantalum is there. Then tantalum will be more than niobium. So if they will ask you, zirconium is more or hafnium is more? So zirconium is less than hafnium. Reason is same, that is a lanthanoid contraction. Clear? So same reason, as Z effective increases, listen carefully, as Z effective increases, what happens? As Z effective increases, size decreased, it became almost same, clear or not? But ionization energy increased. 5D series is more than 4D series. Is this clear to everyone? Dekh lo. Because this is the last important point. After this also many points are there, fact based questions are there, but we are not interested much. Is this clear? Arun. So all of you have subscribed Gosalite channel. So the notification comes on time once the class is started. Okay, fine. Okay, nice. Chalo. It will be visible on YouTube also, na, कि these live classes are going on. So it is. Today meeting is there about Telangana registration. ठीक है, maybe. ठीक है. They will inform you in the group also about this. चलो ठीक है. So other people can also see. It is not restricted to only Gosalite family. It is means open to everyone, I think. Na? Anyone from anywhere can watch the video. ठीक है? चलो fine. So let's come to the next point now. So these are the things. ठीक है, fine. But now I am writing few things which are fact wise. I am directly writing the values. ठीक है ना? So whenever there are few questions which are based on facts, then what happens now? Options help us. ठीक है ना? Options help us to tell the correct answer. 2-3 options will be eliminated. Only one will be left. So if you are not knowing few things, you can apply elimination method also. Like I am writing the ionization energy of few compounds like nitrogen, oxygen, phosphorus, and sulfur. ठीक है ना? You know nitrogen, phosphorus, oxygen, sulfur. ठीक है ना? So what happens कि nitrogen is more than oxygen, phosphorus is more than sulfur. ठीक है ना? Oxygen is more than sulfur, nitrogen is more than phosphorus. So we can compare many, but it is difficult to compare phosphorus and oxygen. It is difficult to compare phosphorus and oxygen. So we have directly written like this. How you can remember this? In the messages we write like nowadays, we don't write yes, we don't write no. What we write? We write yup. We write nope. So you write this only nopes. ठीक है ना? Yups, nopes, yuppie, like this. So nopes you can remember. The other one also you can remember. See, we are having here oxygen, sulfur, fluorine, chlorine. So you tell like this कि fluorine is more than oxygen, chlorine is more than sulfur, oxygen is more than sulfur, fluorine is more than chlorine. But it is difficult to compare oxygen and chlorine. It is difficult to compare oxygen and chlorine. So we have remembered like this ki FOCl, fossil. You can say fossils. You can say fossils like this. So few things we have remembered only. The next one like boron is there, boron, aluminium, and we are having here carbon, silicon. You know ki carbon is more than boron, silicon is more than aluminium. In a period ionization energy increases. Boron is more than aluminium, carbon is more than silicon, but it is difficult to compare boron and silicon diagonally. ठीक है ना? So finally what we say, बताओ. Finally, we have written one order like CBI. You know CBI rates going on so much. So you can remember CBI or CBSC is there. You can remember CBSI. Your choice. ठीक है ना? And the last one will be what? Aluminium you can put. One more data is there. Suppose we compare lithium and magnesium, then what we generally think कि lithium can be more, but finally what is the answer? Magnesium. So these are few fact based. ठीक है ना? These are few fact based things which will help you in solving the questions. Which will help you in solving the questions. So you can remember it. One more question is there in which they ask you stability of aluminium ions. So Al3 plus is there, Al plus is there, and Al2 plus is there. So the stability order is like this. This can be explained on the basis of electronic configuration. ठीक है? What is the configuration of aluminium 3 plus? 2p6 noble gas. ठीक है ना? If you can tell Al plus, it will be 2H2 fully filled, and this one is what? 2S1. So you can explain this on the basis of configuration also and ionization energy difference also. So it's up to you, but I will prefer कि भाई याद कर लो. ठीक है ना? Few things we can remember also. ठीक है? Fine. Just check these things. So this is all about the exceptional points. This is all about the exceptional points and miscellaneous points we are writing now. One thing we can see this also, see, we can say these points key as positive charge on an atom increases. What you can comment on ionization energies? What you can comment on ionization energy? Can you tell? 4D is more than 3D. No, 4D is not more, na? 4D is less. Saranya, 4D is less. Where we have written something or what? 3D is more. See here, 3D is more than 4D. Down the group it is decreasing. 4D should be more than 5D. But this is not true. Okay, na? 5D is more. Is it clear? So this point we can write ki as positive charge increases on an atom, ionization energy increases, because we are talking about consecutive ionization energy only. Like suppose you are talking about M plus, M2 plus, so ionization energy increases. In a general way we can say this thing also ki as negative charge increases, then generally ionization energy decreases. Like suppose if I compare O2 minus and O, what you will think? Who will have more ionization energy? People confuse here. People get confused. What they get confused? Because sir, O2 minus very good noble gas configuration, but this is not true. In electron affinity you will study ki no one wants to take the second electron. No one wants to take the second electron. So in case of anions, don't focus much on configurations. ठीक है ना? Forcefully you have given him. Forcefully you have given him. So oxygen is more. What you are saying, Dinesh? Electronic configuration of Al2 plus. What it will be? 3s. I should write here 3s. I think na. These two values, 3s2 is there. I think this will be 13. So we are having okay, you can change the configuration part. Okay, once see the configuration, 2p6, 3s1, and this will be your 3s2, na? And this will be your 3s1. 3s I should write, na? This only you are saying? Okay, correct, fine. Means you can understand the feeling. ठीक है ना? Mainly we were interested in NH2 and NS1. Clear with this point? ठीक है? So we are having fully filled and the other one is nothing. Got it? Okay. Then good, fine, no problem. So few things, these things you should keep in mind. Okay, last point now I'm going to write. In the very beginning class only I told you about ionization energy and ionization enthalpy. Do you remember something? Are they same? Ionization energy and ionization enthalpy, are they same? What do you think? They are not same. They are not same. In fact, it is written in NCERT, and that too twice. In the periodic table, you will find in the lower part, small letter, there is something written. And again, you will find this in thermodynamics chapter, green color box. They are writing about ionization energy, ionization enthalpy, electron affinity, electron gain enthalpy. But I also told you one thing. What I said? कि practically it will not make any difference in the trend. ठीक है ना? ठीक है, for knowing we are fine, but it will not make any difference in the trend. ठीक है? Everywhere they are writing I. Now no one knows what is that I. I is ionization energy or ionization enthalpy. ठीक है ना? They are writing simple I. ठीक है? Because trend will not change. Ionization energy is increasing, means ionization enthalpy is also increasing. So what we have written at that time, do you remember something? Ki ionization energy is defined at, what we are saying, batao, defined at absolute zero. What do you mean by absolute zero? Jaldi batao. Absolute zero. Absolute zero means 0 Kelvin. And ionization enthalpy this is written in thermodynamics, green color box. Ionization enthalpy is defined at any temperature, your choice. So you can say like this, ki at 0 Kelvin, both are same. Both are same. And one formula is also written there. See everyone, one formula is also written ki ionization enthalpy is equals to ionization energy plus 5/2 RT. Now in thermodynamics they will tell you ki हाँ Cp value is there. So Cp value for monoatomic gas. ठीक है, but ठीक है, finally we have to know only this much. We should have an idea only. ठीक है ना कि ionization energy and ionization enthalpy, if we see technically it is different, but in the trend it is not going to make any difference. ठीक है, so this is all about ionization energy, which we should know at least. Many more things are there. ठीक है ना, but NEET, they are not going beyond NCERT, so why to bother about other things? Okay, अच्छा, one more thing is there. Did I tell you about the first and second ionization energy of second period elements? They ask few questions based on this also. First and second ionization energy of second period elements. Is there any change? ठीक है, so last question, final question. ठीक है ना, लास्ट क्वेश्चन, फाइनल क्वेश्चन ऑफ आयनाइजेशन एनर्जी की कंपेयर I1 and I2 of second period. ठीक है, so not very much difficult, we can do it quickly, and then we will move to electron gain enthalpy section. We will move to electron gain enthalpy section. ठीक है, फाइन. Okay, what you are saying, sir? There is change. What change you are saying, Bhavyashri? अच्छा, change in trend you are talking about. हाँ, ठीक है, few changes are there. I will mention it now. हाँ, electron affinity there for exam. Electron affinity there for exam. Till electron affinity we have the syllabus. Till electron affinity. Fine. अच्छा, all of you are doing only online classes, or you have joined anywhere local places also near your home? What is the status? Okay. Fine. See, NEET syllabus, then NEET syllabus means you can say NCERT part. If you are comfortable, you can read NCERT, and we are helping you also. Achha, many people are there ki those who are attending online now and they have enrolled ki theek hai, when I will go offline I will attend their classes. Okay, chalo theek hai, fine, no problem. Anywhere we will study anyhow. ठीक है ना? So see, let's compare about ionization energy one first, which I think everyone knows. Like second period elements are lithium, beryllium. We will do it quickly. Okay, we will do it quickly. You just keep telling me. We will save some time. ठीक है? And lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Clear? Then what we have to do? I will write the configuration. Lithium, what is the configuration? 2s1. Beryllium, 2s2. Boron, 2s2, 2p1. Then you will say carbon, 2p2, 2p3, 2p4. Then what is there? 2p5, 2p6. Done? Okay. Now you will say, sir, you have told generally the order should be like this. It increases in a period, but there are few changes. There are few changes. What few changes? Anyone will come, don't worry. We are all same. ठीक है. So we know कि अरे we have to exchange. What we have to exchange? Beryllium is more than boron. Nitrogen is more than oxygen. So finally, what is the order of ionization energy? 1. Ionization energy 1 order is like this: lithium, then we have boron, then we have beryllium, then we have carbon, oxygen, nitrogen. Then what is there? Fluorine, and then we have neon. So oxygen, nitrogen we have changed, boron and beryllium we have changed. And I told you that question, do you remember? 2p3, 2p4, 2p5. People will see 2p3 are half filled maximum. No, fluorine is there. Fluorine is 2p5. It is more than nitrogen also. Did you remember this question? Yes or no? Because many people think, they see 2p3, or 2p3 half filled maximum. Not true. It is more than oxygen family, not more than all. Is it clear? Okay. Now let's talk about second ionization energy. How we will talk about second ionization energy? Listen. So after removing one electron, now again I am writing the elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Clear? So after removing the first electron, can you tell the configuration after removal of first electron? After removal of first electron, what is the configuration? 1s2. Sir, this is the helium configuration, noble gas. Got the point? What will the configuration of beryllium? 2s1. What will the configuration of boron? 2s2. What will the configuration of carbon? Jaldi bolo. 2p1, 2p2, 2p3, 2p4, 2p5. All will be shifted by 1. ठीक है, clear? Now what we see, lithium is having noble gas configuration, helium configuration, so it is having very high ionization energy. Clear? Then what you have to do? See, you did something for beryllium boron na, jaldi dekho. You have done something for beryllium boron. Same thing now we will do for which element? Jaldi batao. Same thing we will do for which element? Same thing we will do for boron and carbon. Boron, what you will say? Sir, fully filled. Carbon, what you will say? Sir, less penetrated, outside orbital. Is it clear? And what you will do? Sir, oxygen and fluorine. Oxygen and fluorine. So final order. Let's come to the final order now. Start. Final order of I2. See, now generally I expect NEET ask only ionization energy 1. Like this, na, we should remember only at least ionization energy 1 data. ठीक है, one step ahead we are doing ionization energy 2 also, because in many books, many material, they have asked few questions on ionization energy 2 also. So we will write like this: we have beryllium, then we have carbon, then boron, then nitrogen, then fluorine, then oxygen, then neon, and helium configuration, that is your Li plus, will be more. Is it clear? So this is the thing. So just take a look on the last topic of ionization energy, and then we will start with electron affinity. So is this clear? Everyone just see it. Understood everything? So are all these things which we have studied in ionization energy clear to everyone? If it is clear, just give a like quickly. Rest people are also doing. You have seen YouTubers? ठीक है? Like, subscribe and what? Click the bell icon. ठीक है? Okay, fine. चलो. ठीक है, fine. Okay. Okay, so let's start with the other topic now. You can practice some questions. I am again telling you, see, practicing questions is very important. ठीक है ना? Means without practicing question, we cannot go and give the exam based on only theoretical concept. Some people are there, like students over here also. We were saying, "Arey sir, I read the notes subah se shaam, morning to evening, but then also marks less." Then we ask them, "Arey, did you solve the questions also?" They say, "No, sir." Not true, not correct, na? Not correct way. You read, you solve. You read, you solve. Before going in the exam, you have solved at least 50 to 100 questions, depending upon the syllabus. Okay? And now you can give the exam very nicely. You will find a difference, clear difference you will see. Here, this is the same question in the paper which I practiced from the material or the book. Okay, na? Those who don't practice question, they go and see there for the first time. Nah, it is something like this. I was telling you, na, कि suppose we give you some, suppose there is war, we give you gun, and without practicing send you on the border. Is it correct? No. ठीक है ना? So at least 50 questions, ठीक है ना? So some questions anyhow you will have to solve, and you have to solve the same thing again and again, Bhavya. That's why we say. Many people think like this, na, I will solve some question from this book, some question from that book. This we say ki don't do. Whatever you are solving, solve the same thing again and again. Okay, so let's come to the next part. That is your electron gain enthalpy. Electron gain enthalpy. How we will represent electron gain enthalpy? Delta H Eg. So you can say means it is क्या बोलोगे? Reverse type? नहीं. In ionization energy you are taking electron. In electron gain enthalpy you are giving electron. Clear? Now sometime what happens ki generally, listen, generally this definition is written in many places ki it is the energy released when electron is added. So it is written like this, it is the energy released. So most of the time energy is released only. But somewhere energy is also absorbed. So in NCERT they have written nicely. What they have written in NCERT? Jaldi batao. Ki it is the enthalpy change. It is the enthalpy change. Where, what you can say, it can be released also, it can be absorbed also. So released or absorbed. When this will happen? When an electron is added to valence shell. Again same thing, valence shell of isolated gaseous atom. It can be released or absorbed. Anything can happen. Is it clear? Done? Okay. So it is the enthalpy change, release or absorb when electron is added. Like I will give you example of fluorine. Everyone knows. Achha, this thing I have told you na, ki gaseous atom should be there. You give one electron, it will be converted into an anion. In the NCERT, they will also write in the isolated gaseous atom to convert into anion. They write like this: convert into anion. Okay, fine. We understand these things. Delta H value for this reaction is equal to delta H Eg, and in this case it is negative. For fluorine, this value is negative. For fluorine, this value is negative. Now, suppose if anyone tells you, I will write like this, ki A gas plus 1 electron will give rise to A minus anion formed, and slowly, silently, they will write here aqueous to confuse you. And then what? They will write here ki delta HR is equals to delta HEG of A atom. Is it correct? Everyone see here, is it correct? Jaldi dekho, jaldi bolo. No, wrong. Gaseous atom, fine. You will add one electron, array will get gas, na? But what you have done? You made gas, then you put in water, dissolved. Now you are saying, ki sir, so this is not true. Clear? So see the question nicely. Okay. So come to the next point. What is my next point? Next point is like this. Suppose fine. Now I will write the correct one. I will not write anything wrong. So I will write A minus gas. Is it clear? So this is electron gain enthalpy. Now this value is negative or positive. You tell me. Here delta H Eg can be negative or positive. It can be both. It can be negative also. It can be positive also. See, we have said now कि first electron gain enthalpy can be positive or it can be negative. Anything can be there. It can be positive also, it can be negative also. Like fluorine, it is negative. But for nitrogen, it is positive. For noble gas, it is positive. Clear? So now let's understand ki what do you mean by this negative positive? What is the significance? Do you know? More negative value means what? More positive value means what? What is the significance of this negative and positive? So we understand it in this way. Listen, we say like this, ki you added one electron to A and it released energy. Okay? Means what? It is getting stabilized. Achha, you are saying that thing. Okay, fine, correct. This is exothermic and this one is endothermic. Correct? No problem. Okay? So we say like this, listen carefully. Everyone now focus. Everyone now focus and listen this point. Very important point. We say like this, ki we added one electron in A. You got A minus gas. What you got? You got A minus gas. Clear with this point? You got A minus gas. So if you are willing to take the electron, you became stable, you will release energy. Release energy means what? You became stable. You were able to take the electron. You were accepting the electron easily. So we say like this, if delta H is negative, means electron added easily. Means you took the electron and you released energy. It happens like this. Like suppose you get a good rank in NEET. Now what you do? Suppose you get a good rank. If you study, you will get it also. Suppose you get good rank in NEET. You get a medical seat. What happens? Next day, parents are distributing sweets. You are giving party to your friends. No? Huh? Same thing. It took the electron, very happy, energy released. I am now stable. Clear? Got the point? So if you are willing to take the electron, if electron addition is easier, then you will release energy and you will become more stable. On the other, so this is, if I want to write in the example part, what I can write, can you tell? Who will have negative electron gain enthalpy generally? Who is happy to take the electron? Who becomes stable after gaining one electron? What you can say? Sir. Tell me the first letter. Halogen, not only fluorine. You can say halogen. Okay? Now come to next part. Delta H is positive. What do you mean by this? Delta H is positive means what? It is not releasing energy. You are giving energy. Energy is absorbed. So it is happening like this. Ki I was giving electron to A. A is not taking electron. So I gave him some energy and electron. So forcefully I am adding electron. Very good, Vijay. Forcefully I am adding electron. Okay? Forcefully I am adding electron. Okay? So what you will say? Ki addition of electron is difficult. Addition of electron is difficult. Okay, na? What example you can give? Who does not take the electron? You can say noble gas. Okay? Noble, there are many more examples, beryllium, magnesium, nitrogen, but I am writing two things, nitrogen atom and noble gas. We will write these all things once again later on. Clear? O minus, second, Saran, we are talking about that second ionization energy. Okay? We'll come to that point also. Is this clear? So can I say ki more negative electron gain enthalpy? That implies what? More energy released means what? Easier acceptance. easier acceptance. Can we say like this? More negative electron gain enthalpy means what? Easier acceptance. Can we say like this? Tell, jaldi bolo. More negative electron gain enthalpy, more exothermic means what? Easier. Electron taken easily. Am I correct? Yes or no? Sir, if electron is gained and attained half fill, that is, then you can say it is taking electron, it is willing to take electron. Negative and positive value we cannot comment directly for any element, but Rakesh, one thing is clear, ki those who are gaining electron and getting half filled configuration, they have more tendency to accept the electron. We'll write that point also, ki carbon family is having more tendency than nitrogen family. Is it clear? देख लो, बोलो भाई, ठीक है? So more negative electron gain enthalpy means more acceptance. If I write more positive, then what you will say? More positive electron gain enthalpy means what? No. Then what will happen? Electron not accepted. What? Easily. Got the point? ठीक है? ठीक है? Difficult. It is difficult to add electron. And first electron gain enthalpy can be anything. First electron gain enthalpy can be anything. It can be negative also. It can be positive also. ठीक है? Now see, I am writing the next point and the important point. What is the next point and the important point? It is like this. Same thing I am writing. कि first electron gain enthalpy. देखो, first electron gain enthalpy means what? Delta H Eg1. First electron gain enthalpy can be positive or negative. But what? From second onwards. From second onwards, it is always positive. ठीक है ना? This means what you know? कि first electron तो there is yes no case. कि हाँ ठीक है, some will say कि give me, someone will say no I don't want. ठीक है? In first case there is yes no case. कि someone will say कि ठीक है give me. This is very important point. Don't ignore this. Very important. 2 points are there in electron gain enthalpy which is very important. One point is this. And second point is the exception. Second point is the exceptional case. Got the point? समझा बच्चा? ठीक है? Okay, first electron there is yes no case. Some are saying yes, some are saying no. But for the second electron, all are saying no. I don't want electron. Means what you are knowing, you know. If A is there, I give him one electron. I give him one electron. It becomes A minus gas delta H Eg1. This can be positive or negative. ठीक है? But from second onwards, give electron to A minus gas. अरे don't want to take A2 minus gas. ठीक है ना? Delta H Eg2. This is positive. Come to the next part. If you will say, I will give the third electron, array again positive and more positive. It will be again positive and more positive. I am confirmed, sure, no exception. Got the point? No one wants to take the second electron, third electron. First one, theek hai, fine. Clear? Now, what is the reason behind it? You will say, sir, you are so much sure about it. What is the reason? Ki no one wants to take the second electron. What is the reason? Always, no exception. Like there is that point, na, ki successive ionization energy always increases, no exception. Similarly, this is also there. Ki from second onwards, electron gain enthalpy is positive, no exception. Clear? So what you will say? क्या बोलोगे? बोलो भाई. What is the reason? Fully filled? No. Anyone knows the reason why from second onwards electron gain enthalpy is positive? See, zoom. ठीक है? Repulsions. Now you are saying a bit correct. See what happened now? Initially, this was a neutral atom. You give one electron, it becomes A minus. Now it is rich. When you are neutral atom, ठीक है, normal. You gain one electron, now you are electron rich. Now what will happen? देखो, this electron will come and you are already having electron. So there will be, what will be there? Repulsion between the existing electron and the approaching electron. Clear with this point? Is always positive due to, you can add here, due to what? Due to repulsion between whom? Existing electron and whom बताओ जल्दी? Approaching electron. The electron which is coming and which is already there, they are repelling each other. They don't want the next electron. Clear? So everyone will know this point. All of you will remember this or you will forget. बोलो, भूल जाएगा? मर्जी पोया? You will remember or not? No? Okay, chalo, theek hai, fine. So this is one of the important point. Clear? Chalo, fine. So this is one very important point you should keep in mind. Now we are going to do one question which relates ionization energy and electron gain enthalpy. But before doing one question, I will tell you one more thing. Bolo kya? Huh? One theory part is there. We can see that theory part also. We'll take 10 minutes of class. No. See, I'm giving you one point. Now we are going to see electron affinity and electron gain enthalpy. We should do that part or we should do one question and the rest will continue in next class. One class should be there tomorrow also, I think. 7 p.m. zoology class is there. Okay. So you want gap? Okay, so let's do one question only and electron affinity concept I will tell you in the next class. Okay. So see, they give a question like this, ki if ionization energy of Na, is suppose 7 electron volt. If ionization energy of Na is 7 electron volt, find electron gain enthalpy. Electron gain enthalpy of Na and Na plus. This question they ask. Listen everyone. This question they ask ki Na and Na plus. So now how you will tell? You should not say ki sir there is no numerical, there is no formula, how I will do. Arey, answer is there only. Okay, Saranne, you are telling ki minus 7 electron volt. Whose? Na or Na plus? Na. So this is the twist in the question only. I know you have seen this question before also, but we have twisted something. Okay, now see how we should do this question. First of all, whatever they have given, we should write it. Ionization energy of sodium. What do you mean by this? Ki sodium gas is there and you remove one electron and you are getting Na plus gas. Is it clear? This value they have given, ki ionization energy is 7 electron volt. Clear? Write the reverse of this reaction. Write the reverse of this reaction. You will write Na plus gas plus 1 electron will give rise to Na gas. What is this reaction telling? Can you tell? This reaction is nothing else but electron gain enthalpy of what? Sodium or Na plus. This reaction is electron gain enthalpy of sodium or Na plus. This is electron gain enthalpy of Na plus. When you reverse a reaction, the delta H value changes, that is 7 electron volt. ठीक है ना? So you should, I should have given the opposite also, I can give. ठीक है? So this is electron gain enthalpy of sodium plus. Clear with this point? ठीक है ना? So I can get this one. Now how to find electron gain enthalpy of sodium? Bhai, I cannot find. This we cannot find because we don't have data. So you will say what? Data insufficient given in the question. ठीक है? So Na plus, these two are reverse. ठीक है ना? So just take care of these type of questions. They can ask you like this also. ठीक है? Na I cannot find, Na plus I can find. ठीक है? Done. So enough for today. In the next class, I will talk about electron affinity part. I am writing here only so that we don't forget. ठीक है ना? Is it clear to everyone? QR code. Okay, QR code share preparing to export. Where it will export? Huh? Outside India. So this is the QR code. So hope you have understood everything. Clear? ठीक है? समीर. Okay. जय बाल्या. ठीक है? हाँ, correct Bhavyasri, but same part we will try to discuss that in next class. Sorry. So hope you have understood everything. Clear? PSPK. Okay, that is also good. ठीक है? So done. Chemistry will help you, don't worry. You just give some time to chemistry. Chemistry will always repeat back and more and more. If you don't give time to chemistry, then chemistry will take revenge. ठीक है? So this is the code you can take. ठीक है? So I think now you are having 45 minutes break. Take the break, eat something, and then you can attend the next class. Sunday, you got one break in the middle of the class. Na? I think Wednesday was off. Wednesday you were not having any class, I think. Okay? So that part only they are putting on the Sunday. Okay? In other subjects, syllabus completed. In other subject, syllabus completed. Okay? So for that only we are doing all these things. Okay? Chalo. Fine. So hope you have understood everything. Practice questions I am saying again before going in. Okay. So before going in to give the test, you should practice few questions. Okay? So hope everyone is clear. Thanks everyone. Bye-bye. Bye-bye. We will meet again tomorrow. Done? Okay. Thank you, Swati. Sharanya. Bye. Arun. Okay, nice. Chalo, done.